everyone, welcome back to my YouTube channel. Again, my name is Rikami Escasugano from ACE31, and for today's episode, we will be having our experiment number 4 for the 8-bit interrupt change. For our objectives, we aim to understand how interrupt on change or IOC works, and we aim to apply IOC for controlling our LEDs. Again, we will be needing the same IC, which is this one, a 220 ohm resistor, an LED, a breadboard, connecting wires, our picket 3, and 4 is our power supply. So we just have to follow these procedures. And now let's start with our MPLAB XIPE. So we have to create a new standalone project, and then let's click next here, and then we will be using the same IC again. So PIC 16F18875. AC 16F18875, and then let's click next here, and then let's select the compiler, and then next. Then this will be experiment for Casablanca, and then let's click finish. So let's save this one. Okay, and after saving it, let's go to our peripherals, which are the system module, the interrupt module, and the pin module. So let's just wait for it. So on the top of our screen, here is our pin module, our system module, and our interrupt module. So we have to open our pin manager and then find our pin module. Okay. So from our pin manager, let's select the correct package for our IC. So this one, I guess. And after that, we will be clicking on the port A or port 4, RA4 of our pin manager here. So port A4 here. And we should set the blue lock symbol to change our output here. So I guess this will be click, so the output should be green. Okay, and you should do the same on our port B. Okay, port B here, so port B4, and then in this pin the input should be locked, so the input should be green, and this should be appearing on your screen. So we have to close our pin manager. So let's go to our pin module here, and then so our RE4 should be our output. So output should be clicked and analog should be unclicked, okay? And our RB4, okay, let's change the name of the RE4 to T2 LTT. So that's the name of our RE4 wherein we will be connecting our LTT. So we have to select RB4 pin here, and RB4 will be the input, and we'll read the switch using the interrupt on change negative H or IOCN. So it needs to be selected. So we should change the pin name to SW1. So SW1, and this one IOC here, it should be negative. Okay, let's check negative here. So this should be on your screen right now. And after that, we have to close our pin manager, and let's go to our system module, and then we will be setting our configuration. Select HF INTOSC, and then HF internal clock 4 MHz, and then clock dividers 4. Low voltage programming was enabled, and then we will be going to our interrupt module here, and then the interrupt will be automatically set up because of the IOCN selected in the pin module. So the IOC interrupt is the only interrupt, so it is the first one to activate. So this should be seen on your screen. Okay, so our pin module IOCI here should be enabled, as well as our single ISR per interrupt should be clicked as well. So after this one, we should generate our code. So let's just wait for it. So as you can see, generation completed. So after generating our code, we should have both our .mc file, main.c file here. So from our source files, we can see here our main.c file, and we will be enabling, our global interrupts and peripheral interrupts. So this one, we can enable it by removing the slashes here, as you can see on the screen. So for this experiment, okay, you have to take note that we will not be requiring any code under our main loop because, aside from while one, because the ISR will handle the changing of our input and output pins. But we have to take note that since we will be considering, the interrupt on change function of our MPLAB, we have to change something here on our interrupt manager.c, which can be located in our MCC generated files. So this is our interrupt manager.c file. So as you can see, under our interrupt manager.c file, there is already our pin manager IOC, which is already recognizable by our interrupt manager.c file. So after that, we will go to our pin manager.c file here. Okay. So from our IOC here, okay, we shall find for our default interrupt handler, okay. So as you can see, this is what we are looking for. So here on our IOCBF4 underscore default interrupt handler, so under this one, we will be typing our code, okay, that will let our LED blink for a certain time duration. So we can actually put it here. Okay, let's put it here on the top. So after this one, we will be, okay, let's put a parenthesis. Okay, we can put it on the top or on the bottom. Okay, so let's put our code here, and then I will open and close parentheses, and after this we shall build our code. So let's just wait for it to have a notification saying build complete and build was successful. As you can see here, build was successful. After this, we will be connecting our Picket3 to our MPLAB IPE. Now we will be connecting our Picket3 to our computer. Okay, so let's connect it. So let's just wait for the notification that will tell us to change our operation settings. So now our caution message has popped up already. So this will allow us to edit our advanced mode here. So let's type microchip as our password. Okay, let me type it again. Microchip and then login. And then here on our power, let's select the voltage level to 3.125, and then power target circuit from Picket3 should be ticked. And then we have to browse the new experiment that we made. Okay, Eureka files, and then ECU 30 second sem, and then digital lab and experiment 4, and then our new hex file here. So let's upload it. So let's just wait for the upload. Okay, hex file loaded successfully, and then let's click program. Okay, so let's just wait for the programming complete notification to pop up. And after that, we will be connecting our breadboard to our Picket3. So programming complete. So now let's go to our actual circuit on breadboard. So after connecting our Picket3, okay, so our Picket3 is on active status already, meaning the IC has been programmed and the source code has been transferred to our IC. So after connecting it, we will now be constructing our circuit. So our green wire here, okay, our green wire here will be our wire for our output, okay, where our LED and resistor will be connected. This is on our RA4, as we can see on our MPLAB here. And RA4 is on the pin 6, okay, if I'm not mistaken. RA4 is on the pin 6, right, the pin 6 of our IC. And then we will be connecting an LED here on our pin number 6 of our IC. So let's connect an LED, and let's connect as well a ground, okay, on our LED. And then after that, let's connect our switch on our pin number 37. Okay, we will be using a tactile switch. So let's connect our switch here, and it is connected using this yellow wire here, which is connected to our pin number 37, which is our RB4. So let's connect this. Okay, let's just check the connection. Let's just connect this to the one leg of our tactile switch, and then the other leg of our tactile switch shall be connected to our ground. So you have to take note that VDD should be connected to the positive, okay, should be connected to the positive polarity of our supply, and our VSS should be connected to the ground. Okay, so let's just transfer this one. So okay, this is connected to the first pin, and then the orange wire here will be connected to our positive supply here. Okay, be connected to the positive supply here, and the gray wire here will be connected to our negative polarity of the supply, or our ground. So this will be our circuit for our experiment number 4. So now testing our circuit, okay, so let's first start with our LED not turning on. So if we turn on our power module here, okay, as you can see, our LED is blinking. Okay, so it is blinking because we set the source code of the MPLAB to toggle, meaning it will blink. So to prove that the code is correct, okay, while the LED is blinking, we should put some interrupt, okay? So we click the switch, okay? So there will be an interrupt for the blinking of the LED. So if we turn off the switch, turn on and turn it off, so the light will turn on and will turn off as well. But if I just leave the switch and do not input an interrupt, the LED will keep on blinking. Okay, but again, if we put an interrupt, it will turn on and off. So that allows us to control our components like an LED using our digital input through our switch, letting us control the outputs of our electronic components such as an LED. Okay, so let's proceed to our exploration for our code. So for our exploration of the code, we will be modifying the code in our default interrupt handler such that it toggles multiple LEDs in our output ports. Simply speaking, we just have to add more LEDs in our output or in our pin manager so that we will be able to toggle multiple LEDs, just like what we are seeing in our electronic devices, or let's say, for example, vending machine that we see outside. So I will be selecting 5 LEDs to toggle. So I will be selecting RA0 as my output 1, and then RA1 is our output 2, and then RA2 as my output 3, RE3 is my output 4, and RE4 is my output 5. So this is pin number 2, pin number 3, 4, 5, and 6. So since we already selected 5 pins here from our pin manager, we will generate this one. Okay, let's generate it first. Okay, and after that, let's go to our pin module here, and let's rename all of our components. So since this is the 5th LED, I will rename it as D5 LED, and RA0 will be D1 LED, and then this one will be D2 LED, and then this one will be D3 LED. This one will be D4 LED, and this one will be D5 LED. Analog should be unticked for this 5 outputs, and output should be selected. So let's generate this code. Okay. So after this one, let's generate it. Okay. So let's just wait for it. Then let's go to our pin module. So kindly check if our RP4 or our switch has been set to IOC, which is negative. Okay, this one negative. And then let's go to our system module. Let's check if the system is still the same. And our interrupt module, pin module IOC I should be enabled. Single ISR per interrupt should be enabled as well. So let's check it all. And then let's go to our projects here, and then our source files, and then our main.c file. Make sure that our interrupt here is enabled, okay, by removing our 2 slashes. And let's go to our MCC generated files, and then let's go to our pin manager.c file here, and we will be adding the code, okay, the toggle code for our additional 4 LEDs. So the name for our LED is D1 LED toggle, and then D2. Okay, let's just consider D2, and then D3 LED toggle, and then D4, and then the last one. Okay, the last one will be D5 LED toggle, and then after that, let's click build. Okay, as you can see here on our pin manager, okay, our pin number 2 to 6 has been selected as our output, and still our RB4 here, which is the pin 37, is our digital input pin for our tactile switch. So let's just click this yes to replace the old hex file that we previously created. And as you can see here, there will be a notification saying build successful. So now let's go to our MPLAB IPE. So now, here on our MPLAB IPE, we will be checking if our power settings is still 3.125, power target circuit is still checked. Then operate, let's connect our picket again. Okay, so let's just wait for it to load up. So again, there will be an option here, or let's say a caution, that will allow us to edit our simulation settings. So again, the password is microchip. So let's change the voltage level to 3.125 so our IC would not damage. So power target circuit from picket 3 should be enabled. And then let's upload the new hex file that we created. So experiment number 4. So hex file loaded successfully, and now let's click program. Okay, let's just click this OK. So let's just wait for the programming complete notification to pop up on our screen. So as you can see here, programming complete. So now we will be testing if our code is correct. Let's go back to our breadboard. So now, after connecting our picket 3 to our MPLAB IPE through our USB cable, we will now be disconnecting our picket here. Okay, let's disconnect it. And we will now be modifying our circuit wherein we will be adding additional 4 LEDs on our IC pin. So as you can still remember, we selected 5 LEDs as our output, which is connected to our pin number 2 to 6 of our IC. But first, let me get this wire here and let me connect it to our positive polarity of our voltage supply, and this wire here, which is our BSS, should be connected to our ground. Okay, so now let's start connecting our LEDs. First one will be our LED 4 for our LED 1. Okay, so it is connected to the pin number 2 of our IC here. So pin number 2 is connected here. Okay, so let's connect our pin number 2 here. Okay, our first LED will be connected here. Okay, and the next LED will be connected later on our second pin, but let's first ground this one. So let's ground this one, this first LED, and then the second LED will be connected to the pin number 3 or RA1 of our IC. So let's connect it properly. So this one. Okay, so let's connect this one and then another LED. Okay, positive to negative polarity, and then let's ground it. So let's ground this one. So next one will be on pin number 4. Okay, pin number 4 of our IC. So this one, pin number 4 or the RA2 of our IC. So let's connect this one, and let's connect another LED here. And of course, let's connect it to our ground. So this one, connect it to our ground here. And then another LED, which is our fourth LED, will be connected to our pin number 5 or our RA3. So this one, RA3 will be this line here. So this one, another LED, let's connect it. Then last LED will be on pin number 6 here, which is our RA4. So let's connect it here. Okay, so let's add another LED here. And lastly, let's ground it finally. So let's ground it. Okay, so this will be the connection of our circuit. Don't forget the connection of our VDD to our positive supply, and then our VSS to the ground. That is important. And then our switch will be connected to the RB4 or the pin number 37 of our IC, and then this will be our tactile switch here. Okay, I hope you can still see it. Okay, this will be our tactile switch, which the first leg is connected to the pin number 37 of our IC, and the other leg is connected to the ground. So this will be our circuit. Now, to prove if our circuit is correct, and at the same time our source code using our MPLAB software is correct as well. So we aim to consider this 5 LEDs here as our output, okay? And we aim to prove that by connecting a digital input through our tactile switch, we will be able to give an interrupt to our circuit, and this interrupt will let us control the operation of our LEDs. So now let's turn on our voltage supply here. So as you can see here, the LEDs are continuously blinking, okay? The 5 LEDs are continuously blinking. But, okay, these are blinking because we set the IOC for it to blink, okay? And we set our source code to LED underscore toggle. That's why the LEDs are blinking. But once we put a digital input, okay, once we give the circuit a digital interrupt through our tactile switch, okay, as you can see here, I am turning on and turning off our circuit. So as you can see, every time I turn on and off our tactile switch here, the lights are turning off and on as well. So this allows us to issue an interrupt to our circuit, and this let us understand that we will be able to control our electronic components using our interrupt or IOC command here in our MPLAB software. So this is really awesome. So that is all for our experiment number 4. I hope you learned something from our experiment number 4, and I hope I will be seeing you on our next episodes. Thank you and bye! Proceeding with our conclusion, overall, the experiment let us understand the PIC microcontroller's interrupt and change IOC function, which is controlling the output of an LED. We can determine the digital output of the LED, whether it will turn on or off, using an interrupt with our digital input through our switch with IOC We can control the operation of electronic components using interrupt bias switch. So that's all. Thank you.